Hi, my name is Anul Mahidaria, and thanks for joining me on this first session on Introduction to Kicad and FreeCAD. Over the next 4 weeks, I hope that I would be able to walk you through the basics of these two programs. So once you're over the first initial hurdle, it becomes easier as you practice and become more proficient at it. So I hope all of you have checked out the HackadayU project page. So here's the hand-drawn schematic. My thought was to use an 80 tiny 85 to drive a couple of RGB LEDs, the WS2812Bs. I've broken up the sketch into 4 sections. There's a controller, which is the 80 tiny 85. You're going to use one pin as an output that drives the RGB LEDs. And we are planning to use a second pin connected to a switch, which can act as a user control of sorts. Next to the controller, we have the WS2812 LEDs, but it's likely that we might want to add more of these LEDs externally. So we are going to add an output 3-pin header. We need a way to program the 80 tiny. So that's our interface for programming. And once we're done with programming, we can still use all of those pins that are broken out. Finally, there's a pretty simple and straightforward power supply. There's a 2032 batteries in series to give us 6 volts, and a couple of capacitor and a LDO to get us the 5 volt that the circuit requires. So we have a 6 volt input and a 5 volt output, so we'll have to be careful in making sure we choose an LDO which has the lowest possible dropout voltage. We can add a 2-pin header where we can attach an external battery source. So that's essentially the plan. So with that, let's get started with Kicad. Today, the plan is to replicate the hand-drawn schematic in Kicad. So get all the parts, wire it all up, put all the values and references and so on. We'll look at how we can create a custom symbol library specific to this project, and how you can possibly edit and create your own symbols for Kicad. And when you do, if you already used it earlier, you might have an existing project pop up, but we want to start off with a new project, which you can do via the file menu, or there is a new project icon over here. Let's create one. I'll use my desktop and create a new folder called HackadayU, and within that, create a new folder called Kicad. And within here, I'm going to create a project called tiny underscore blinky, and save that. Once you do that, Kicad creates 2 placeholder files, one for schematic, and this is what you see on the left side in the folder view. Going from left to right, it is in progression of how we would be using the different programs. The first icon is for the EEschema schematic capture or editor. There is a symbol editor. Then there is the PCB new, which is the layout editor, and the footprint editor, which you will use to create your custom footprints. There is a built-in Gerber view through which you can verify your design before you send it off for fabrication. If you'd like to add custom logos to your project, there is a handy utility called bitmap to component converter. There is a bunch of calculators available, which lets you calculate several things. Like this one, for example, lets you calculate the values of the resistors if you have an adjustable voltage regulator. There is a track width calculator. There's a transmission line calculator. And there's a nice handy board classes table. That's the bunch of calculators that you get in the calculator app. And there's a custom template designer if you want to design your own page layout. The other thing to do before you get started is in preferences to configure your parts. You have already downloaded 3 GitHub repositories, the symbols, the footprints, and the 3D packages. And you need to tell Kicad the location of those directories over here. So with that set, let's fire up EEschema, which is here. and you're presented with a blank slate. There are three toolbars that you essentially use. On the left are a couple of system parameters that you set. For example, the first one either shows or hides the grid dots. You need to set the measurement units that you'll be using. With schematic editor, it really is irrelevant to use metric or imperial. You can have long or short cursor shapes. You can show hidden pins. So that's the toolbar on the left. At the top is some of the commonly used tools and icons that you would find in most programs. There is a way to save files. There are a couple of zoom buttons. You can zoom in, zoom out, zoom to a window. You can redo and undo changes. You can cut, copy, paste. Important one for us is the second icon, which says Edit Page Settings. If you want to scroll and zoom in Kicad, your scroll wheel on your mouse will zoom in and out like so. If you press the Shift key and then use the scroll button, you will scroll in the vertical direction like this. And if you use the Control and the scroll wheel, you move in the horizontal direction, that's left and right. So let's first set the page settings. Click on the Edit Page Settings icon, and that brings you this dialog. If you want to use the current date, you can push it to the issue date. If your design is going to have multiple layers of hierarchy, you can make sure that this information gets exported to all of those sheets too. Revision, in this case, we are on version 1, so let's put that in. Title, name of the project is tiny_blinky. Company, you can put whatever. I'll put Hackaday. Comment, I can just add some comment. Introduction to Kicad and FreeCAD. I can say okay. I zoom in over here. You can see that this information has been updated over here. At the top, we also have a couple of other Kicad specific icons, and they have been placed in the order in which you would use them while working on a project. There is a couple of ones that refer to libraries. So the first one is to create, delete, and edit schematic symbols. And this takes you to the symbol editor, like so. There is also a browser if you just want to look at the various symbol libraries. And there is similarly a footprint editor. So this is for the PCB footprints. And then there is an annotate schematic symbols icon. Kicad, when you place any component on the schematic, it doesn't number it right away. So you can keep adding components and they will all be without any reference designations. Once you're done with your whole layout, then you can call up the annotation feature and annotate the various components. There is an electrical rules checker, which performs some basic electrical rules like checking if two power outputs have been connected together, or if you have, let's say, any unconnected pin left floating in your schematic, then it warns you about those. The next tool is the assign PCB footprints to schematic symbols. Again, usually when you place a symbol on schematic, Kicad doesn't automatically assign a footprint to it. With the current version of Kicad, a lot of parts often come with their footprints associated with them already. But some of the common ones, like let's say a resistor or a capacitor, footprints aren't assigned. Once you have done the annotation, once you've assigned all the footprints, your schematic is pretty much done. And then you're ready to create a netlist, which is basically the glue that connects schematic editor to the PCB layout editor. There's also a bill of materials generator, which uses several different scripts to generate bill of materials depending on what your requirements are. And we'll look at back import later on. And then finally, on the right side is the actual tools that we'll be using to draw the schematic. There's a selection pointer at the top, and there is a highlighter next to it. You can place parts using this icon. power connections are treated a bit separately in Kicad, and there is a special library for power connections. You can then draw wires using the draw wire or the place wire command. You can also place buses, and if you're using buses, you need to have bus entries and exits. You can combine multiple buses and break off a bus into sub buses. If you have any pins that are not connected for any of the symbols, it is essential to place a no connection flag over there so that the electrical rules checker doesn't throw up an error. Place junctions. Most of the time, Kicad can place junctions automatically. Net names or net labels. This is extremely handy. All the connections that you make in your circuit, you should try and name them as much as you can so that it helps you find where those connections are going. Kicad also allows you to have a hierarchical layout for your schematic, which means you can have a sheet and then you can embed a subsheet which has some other section or portion of your whole circuitry. You can have a sheet and then multiple sheets within that and so on. And there are two icons here that let you navigate to your hierarchy. There is a navigator and a list of sheets that you can choose. So the next couple of icons over here allow you to create a hierarchical subsheet within this design. And then finally, there's a couple of drawing tools, and you can add descriptive text on your schematic. So with that quick introduction, let's get started with our actual schematic. I will keep it handy over here so that I can look at what I'm doing. It's the same hand-drawn schematic that I showed you earlier. And we start off with placing an ATtiny. That's going to be our first action. As far as possible, I will be using commands that will be visible to you. So click like this so that you can see what action I'm doing. But most of these can also be done using hotkeys. For example, center is F4, zoom in is F1, and zoom out is F2, and so on. And as you get proficient with the program, you will find it much more efficient to start using these hotkeys. If you'd like to have a look at all of the existing hotkeys, you can go to Preferences, and under Preferences again, under Hotkeys, you will find a list of all of the existing hotkeys. Some of them are pretty self-explanatory, like M moves a particular item, C copies it or duplicates it. If you want to add a symbol, you use the alphabet A. If you want to add a power symbol, you use the alphabet P. All right, so we're good to go with creating the schematic. First thing you're going to do is use this toolbar icon called Place Symbol. Once you click on it, your cursor changes to a crosshair with a pen. You can bring that somewhere within your sheet in the center. Let's say click once. It shows up the list of all of the libraries that are installed on your system. So these are your schematic symbol libraries. And we are looking for an ATtiny. So let's try and use the search bar to look for ATtiny, but I don't find any. And the reason is, if you look down here, where is it? Under MCU microchip, you'll find that there's 80 mega and ABR, but no ATtiny. That's because I haven't enabled that library. And to enable additional libraries, the way you do it is you go to Preferences, you click on Manage Symbol Libraries. There are basically two tabs: global libraries that are available for any and every project that you open up in Kicad on your system, and project-specific libraries that are limited only to the current project that you're working on. So as you can see, I have not enabled each and every library. So in this case, let's go down and see. Here it is, ATtiny. It is unchecked, which is why I can't use it. Put a check mark on MCU microchip ATtiny and say OK. And now if I click here again to place a part, and in the search bar type ATtiny, I get a bunch of ATtinys. This is still a long list. I know I want to use an ATtiny 85. So let's make that list shorter. And there's 6 versions available. So there's an 85-20 MUPU NSU and a -10 MUPU NSU. The PU is the DIP 8-pin package, which is what we want to use. I'm going to click OK on it, and it's still floating. You can move it around to where you want to place it, and then you click it one final time, and it gets placed over there. So that's your 80 time here. The next thing I need to add is a switch and a resistor to act as the input. So I can just click somewhere else. It brings up the library browser. I need a switch, so I can just start searching for it as SW. Shorten our list. If you want to use a push button, so switch push. And yeah, the first one I get is what I want to use, a push button switch. All right, so let's choose that as okay, still floating because I can move it around. And I will introduce you to a new command here. Before you place it, if you press the R key, you can rotate this symbol. If you right click it, you can, under orientation, choose what orientation it needs to be. I can select cancel and rotate it once and place it somewhere over here. Press shift and scroll to scroll down. The other thing you can notice is if I click on this symbol and I place my mouse cursor here and press the M key, I can now move it. At the bottom of your taskbar, you'll notice the coordinate system. There is an absolute X and Y, which is capital X and capital Y. And you'll also notice relative dx and dy coordinates. But relative can be useful. For example, if I want to place my switch at this location, which is x 6.5 and y 1.7, I can then place it here. And at this point, if I press the space bar once, you'll notice the dx and dy coordinates become 0, which means these are relative coordinates now with respect to the center of the switch. And this can be handy because I can now choose to place another symbol, come down here, click once, search for a resistor, just type R, and I got the first symbol which pops up is the resistor symbol. Click OK. And now I can place this such that it is oriented in the right position with respect to the switch. We need another resistor which acts as a current limiter for the RGB LEDs. Since you already have a resistor, we can just grab this and place it somewhere else. You can do that using you can do right click and say duplicate, or you can use the hotkey C. Once you do that and you move your mouse key, you can then place it somewhere else. We need to rotate this 90 degrees, rotate it once, and it needs to be in line with pin number 3. I can just bring it here and then use the arrow keys to move it like so and place it here. So that's the resistor placed over here. We are pretty much done with placing parts for this section. So let's wire it up by adding wires. That is using this icon called place wire. You click on that once. Your cursor again changes to a crosshair with a pen. You start off with pin number 8 of your 80 tiny. You go up like so, click once, then bring it to the switch like so. The other end of the switch goes to the resistor. In this resistor, this pin has a round hollow circle that indicates that this is an unconnected pin. You can notice that on all of the other pins. Pin number 4 is unconnected. Once there is a valid connection made to such a pin, the circle disappears like on this pin of the resistor. I start with drawing my wire from here, click once, go down and click once, go left and go up at the same time until I reach this point and then click once. You'll notice that the hollow circles on both of these pins have now disappeared. which means we have made a valid connection between these two pins. Let's also join up this pin of the resist. Click on this once. Click over here once, and your wire is clear. And as you can see, these two wires have crossed, but it hasn't put a junction over here because it's smart enough to know that you don't want that connected. Since this is going to be going to our RGB LED, which also need a ground and 5 volts, we probably ought to bring those wires here as well. So we have a nice pin. So we can start with from here, click once, move down like so, click once, then double click over here so that ends the wire drawing process. And you'll notice the wire now has a hollow square over here, which again indicates that this end of the wire is unconnected. Let's draw a similar ground wire. We start from this point and we move up like so. Let's end it. Oh, we missed out one wire. So let's add that. The input from the switch is going to pin number 2. So I click on pin 2 once, bring my wire here, click once, it adds a junction. Let's add net labels now, which is done using this icon over here, place net labels. Again, the way it works is once you enable the net labels icon, you get a crosshair and a pen, and you can then select where you want to add the net label. So in this case, let's add a net label to this wire, which is the input. So I can click on this green wire. It brings up a dialog box where I can put a label. So this is switch in, SWIN. We can also control its orientation, and then you can also make it bold or italics and so on. Click OK. It's still not placed where you want it because you can still freely move it around. If I place it, you'll notice it gets a hollow square over here, which means this is an unconnected label. And if I want to make sure that it is where it should be, I bring it and place it on this wire over here. Once you do that, it gets connected to this wire, and these 3 wires now have a label known as SW_IN. So let's add a similar label to the output. So I choose place net label. I place my cursor over here on this wire and I give it a name of, let's say, LED. Say OK. Click here once. Just make sure that I save this. There we go. And now let's add in the remaining net labels. Place the wire over here, end it over here by double clicking it like so. Then click on the net label icon, place it on this hollow green square over here, give it a name, be in, select OK, and I can still move it around, so I can rotate it, place it over there. Let's figure out a way to extend wires. So if you right click on a wire like so, and use the first option, which is drag wire. This lets you drag wires like so. Let's drag this other wire as well. Click on G, extend it out like so. And then let's add net labels to these 2 wires as well. So I click on place net label. And this is 5 volts. And place. I can copy a label, right click and say duplicate. Place it over here. I can edit this by pressing the E key or right click and edit. And change the name to GND. There it goes. Next thing we need to do is add the power information, and they are accessed by either clicking on the P alphabet key or this icon symbol over here, which says place a power port. So let's bring the cursor here where the VCC pin number 8 is. Click once, and you'll notice there are just two libraries here, but mostly what you will be using is the one from power. We will just use 5 volts plus 5V as our power symbol. Click on OK, then place it here. And then I need to add a ground symbol as well. So that would come here. Click over here once. It brings up again the power libraries. Click on power, or in filter, just look for G and D and place it here. It makes for a better visual experience if you don't have to draw a wire connecting every ground connection. One way of doing that is I can right click on this wire segment here and say break the wire. And right click on this horizontal wire and say delete this wire, and I can delete this wire as well. I got two wires because I used the break wire function. So we have ground here. We can just copy this using C, move, click once to place it. Both of these pin points are at the same ground potential. Then I can add one over here as well. I can click C to copy, move, click here once to place. Then I can delete this wire by pressing the delete key. So that completes the controller part. Let's quickly add the LEDs, and we can put them in line over here. And in order to do that, we might want to add some space over here to add those components, which means moving this block towards the left. That's pretty simple, as in most of the programs. You click once, you draw a block to cover the whole area you want to select, click a second time, and then using the arrow keys or the mouse, you can just move it like so. And then click it once, and that's it. All right, so let's draw the LEDs part now quickly. You know the drill. We select the place symbol icon. We bring it approximately where we want to place it. Click it once. And in our finder, look for WS281. Okay, here it is. And the LED library has a WS2812B. And I zoom in and I place it somewhere like so. So that's one. And I need 3 of them. I can either copy and paste this, or I can just click here once, and you'll see the first entry is recently used. So that has some of the parts that you've been using here already. You can click on WS2812B, click on OK. Let me just bring it here, and then press the space bar once to make the relative coordinates 0. And then use the arrow keys to move it 1.3 inches along the x-axis, so it lines up nicely. And then I can just right click here, say duplicate, and place it at 2.6. So that gives us our 3 LEDs. It makes sense to add an output 3-pin connector over here. So we are still in the place parts option. We can just click here once, and we look for a connector. So CONN should bring us a lot of connectors, which would be a 3-pin socket. So 1X03. This is the one that we're looking for. Bring it here, and we can place it like so over here. If you want to mirror this along the x-axis, you can press X, and you'll notice pins 1 and 3 have now flipped over. And if I press X again, they flip over again. And if I press Y, it will flip along the Y-axis, so the pins will be pointing on the other direction. If I press Y again, it comes back over here. So we have everything that is needed for the LEDs. Let's wire it up quickly. Choose the place wire command. Let's start from the output pin over here. Click once, draw like so, click once, dragging and drawing, click here once, click here once, and then double click over here. Then we join each of the 3 LEDs to this 5-volt wire, 1, 2, and 3. Let's join the output to this pin, the input of this to the output of this one, input of this to the output of this one. Let's draw a piece of wire here and terminate it like so. And then let's draw the ground connection. So we start here, draw along, click once, draw along here, click once, keep going here to the end, click here once, click once, and then join the LEDs to this ground wire, 1, 2, and 3. All that's left is to place net labels over here. We can easily just join these wires, but since we're trying to figure out how net labels work, we can just copy, move it. But now we want to rotate this label, so press R twice and place it here. You hold the mouse over D in, C to copy, move it, R twice to rotate, place it over here. Over ground, C to copy, move, rotate twice, and place it over here. So that completes the LED part. I'm going to save the schematic now. And we need a way to program this tiny. Looking at a hand-drawn sketch, you can see pin number 5 is main out and secondary in. Pin number 6 is main in and secondary out. Pin number 7 is clock, and pin number 1 is reset. So let's add those labels over here. So we're going to draw a couple of wires first. Like I said, this is purely for aesthetic reasons, but you can add a label directly to the pin as well. So I'm going to add 4 wires like so. And then I'm going to add net labels to these 4 wires. So use the place net label. Click over here once. And this one is MOSI. To point the other way around, so press R twice. Click it here. The next one is MISO, and so I don't have to press the R key twice. I'm going to select orientation as left. Okay, click it away. Next one is clock, SCK, and orientation stays left, so things become faster now. And lastly, the pin number 1 is reset, RST. Save it. We have everything labeled nicely. The next thing to add is the programming header. And the standard SPI header is a 6-pin 2-row mail header. And we're going to use the place component icon. Here it is. 2 columns and 3 rows. Odd even. This is what we want. This is how the SPI pins are usually numbered. Select this, click OK. Click here once. Let's draw the wires here quickly and then place net labels. I'm going to zoom in. I'm going to now select the place wire command. Draw a wire once and double click here to end it so. Then press escape. Let's look at copy and paste now. I can draw a block here like this and say duplicate, bring it here and copy and paste it. Same thing, right click, duplicate, place it on pin number 5. Now I can grab all of these 3, right click, release key, right click, duplicate this block and place it over here. Let's place net labels. Pin number 2 is usually 5 volts. So this is 5 volts. You can also copy labels from somewhere else and just bring them over. So here's ground, you can and click once to place it over here like this. And between 5 volt and ground is a main out, secondary in. So MOSI. Let's go to MOSI. Use C to copy, shift scroll to move, paste. Then let's quickly add the others. MISO. So place mouse over here, C for copy, shift scroll. You want to rotate it and place it on pin number 1. Next one is clock. So SCK. Over here, mouse on SCK, copy, shift scroll, rotate twice, place it here. Then there's finally reset. So copy, scroll, zoom, rotate, place. So that's a program header. And let's save it. Now, if you'll notice, each part has 2 important pieces of information visible. One is its reference designator, which right now has a question mark for all of the parts. And these are the values. This one is the 80tiny 85-20 PU. This one doesn't have a value yet, it's just called R. This one also just called R. Annotation icon, annotate schematic symbols. Once you do that, it brings up a dialog box where there are several options. There's really nothing much to be done in this dialog box except select annotate. So you can play around with the different sort positions and see how things change. But as of now, the parts that we have placed on this board have been numbered. Now, some of the value are not yet set, so we will have to do that. For example, this resistor here is going to be a 10K. Again, there are many different ways of editing this. The fastest way is to hover your mouse over the value and double click it. That brings up the label properties. The other way is to right click somewhere on the symbol and under properties, select edit the value. So let's select this at the moment for this one. And the text is 10K. Click OK. This resistor is right click and edit value. Say 330E for ohms. The other thing I want to name is this connector. Click on E, edit, and D out for data out. So that's my output connector. Let me also rename the program header to, I can hover my mouse over this text and click on the B key or anywhere on this component and press B to edit the value like so. So let's call it SPI PROG for program. And the switch, we can just rename it value to SW, keep it short. Let's save it. Let's look at how to kind of make things a bit easier to read in the schematic by moving things around. So I can hold my mouse on this piece of text over here, click on M to move it, and you can see where the anchor point is, which is the center of this IC. So I want to, let's say, rotate it and keep it along the left edge. I will press R to rotate, bring it where I need to place it and click it once. And that's how you move that piece of text. I'll hover my mouse over U1, press M to move it to a location, click once and leave it there. Same thing with the resistors. I move the values, references inside the rectangle. So hover my mouse over the reference, click M once, rotate once, and place it here in the center. Then take the value, M for move, and then click it to place them. So that's making it slightly more legible and readable when you print it out as a PDF, for example. So at this point, let me save it again. And then let's figure out how we can add a bus. But before I do that, because I want to add the bus to these pins and connect that bus to this program header, let me make some space over here to draw those wires. And in order to do that, I click once, draw a rectangle like that, leave it, and I can right click and do drag block, and then use the arrow keys to kind of move it out like this. And you'll notice that we ended up with two issues here. It dragged these two wires as well, but that's an easy fix. I can grab this and bring it here. I can grab this, bring it here. All right, so we have enough space here to draw the bus entry points, and then we can figure out how it connects over here. So buses, you first have to add the entry points, which is this icon over here. Place wire to bus entry. So you're connecting a wire to a bunch of other wires known as a bus. Click on that once. Let's move over here and click at the end of this wire once. That places this bus entry over here. If the orientation isn't right, you can hover your mouse over this bus entry, right click and say change the shape, which kind of mirrors it. And now to make things easy, we can just right click and duplicate and do it there. Do it again, draw a block, right click, duplicate, keep it here. Then repeat it one more time for the fourth one. Right click, duplicate, grab two, but it's okay. I can take one and delete this one. And then I need to change the orientation. Right click, first wire entry, set this, and we actually have two of them over here, so delete the other one. So we have these bus entries here. Let's add bus entries to these 6 pins as well. So I click on the wire to bus entry icon here. Click here once. Click here once. Click here once. Click here once. Once. Okay. So again, orientations are not right. So I can right click, change the shape, right click, change the shape, right click, change the shape. And for these, I can just right click and move it like so. Right click, move, so right click, move, place. So we have these entries here now, 6 over here, and actually 4 over here. We don't need the 2 for the power, so let's get rid of those 2. We don't need this, and we don't need this. Just going to connect these 4 wires from this connector to these 4 wires on the ATtiny. And we have the bus entries prepared. The next step is to click on this icon which says place a bus and start from here. And click here once. And once you come over here and click it, you can press the end key on your keyboard to end the bus. You'll notice that the circle at the end of this bus entry has disappeared. The circle at the ends of these bus entries have disappeared, but not over here yet. So we'll have to add a bus connection from here to this bus using the same tool. Start from here and I end it over here. And it added a bus to bus junction over here. So now what Kicad has done is take these 4 wires from here and pipe it through a single common bus and then spread it out over this program connector. And if you have a pretty complicated sheet that you're working on and you have lots of buses, you can use this tool to make your schematic easier to read. Save it. So that was description of how buses work. Let's look at schematic hierarchical sheets. And there is a certain method to the madness over here. So let me try and see if I can make it as simple as possible. So first step is to create a hierarchical sheet. Choose that icon. Click somewhere on your sheet once, and you'll notice a block pops up. You can now change the size. Something like this is good enough. It's important to give a reasonably descriptive name rather than the timestamp based name that it selects for you. So let's call this the power supply.sh and give the same name to the sheet as well. So there is a file name and a sheet name. Can be different, but it's usually best to keep them both the same. Click OK, and your hierarchical sheet is now placed over here. If you look at navigate schematic hierarchy, you will get a navigator that will list all of the sheets that you have in your current schematic, and you can click on one of those and enter that sheet. The other one is this icon to leave a sheet or enter a sheet. As with every command in KiCad, there are several ways of doing the same things. I can hover my mouse inside of this block, right click once and click on enter sheet. But the faster way of doing that is also by just double clicking over here like so. And we have a fresh blank sheet here. If you look at the file name, it says power supply.sch. So we're going to add the power supply parts over here and then connect it to the sheet at the top, which you can see as a root. So as usual, we choose the place symbol command. Click once, bring it somewhere within your sheet. Click once, the libraries open up, search for battery. Let's choose this because we're going to be using 2 batteries in series. So this is a good representation of that. Click on OK. Zoom in a bit and paste here, like so. That's your battery. Next component we add is polarized capacitors. So let's look at just typing C brings us, if you look at this symbol, CP is the polarized capacitor. Let's select that, place it over here, press C and select the unpolarized version and place it here. Let's place one connector over here. Socket to pin. Okay. Let's rotate it so it faces the right direction. Let's flip it along the x-axis. So pin number 1 is at the top, and then place it here. So most of the parts are here except for the LDO. Pick your ones. We look for LDO, and we have quite a lot of choices over here. There is a part number that is used pretty commonly, 1117. So there's this one looks like a good choice, the AP 1117-50, and let's use a surface mount device footprint for this. So it'll be a good practice to in terms of placement and routing. Click on OK. Place it here. We have all the paths that we need for the power supply now. We can quickly then choose this wire and start drawing our connection. We start with the input connector and connect it to the input on the voltage regulator. Connect the output to the capacitor. The other end of the capacitor returns back to the input header. Let's connect the batteries like so. Connect the, place it here. Connect this one. Connect ground to pin 1. So that's our power supply. Let's quickly name and provide the values for the components. So this one is, call it V in. So input voltage. Double click on battery and call it CR 2032 times 2 x2. The polarized capacitor, I double click on CP and put a value, let's 470 microfarad, 25 volts. Okay. Output filter can be 100 nano farad. Click on OK. And all the parts have values now. We need to annotate this section now. So let's click on the annotate icon. Click on annotate, close, and we have these parts numbered now. So here's the second sheet, and if I right click here and say leave sheet, I go back to my root sheet. And now the trick is, how do you make those connections between the power supply to this root sheet? And in order to do that, we enter our subsheet first. So double click on power supply. We zoom in a bit. So you want to connect a hierarchical label to a net label. So let me show you how this works. I click on hierarchical label, and I can just place it anywhere. Click here once. And there are three connections going between this sheet and the root sheet. That's the V-in, which is the input voltage. The other one is the output voltage, which is 5 volts. And the third one is ground. Those are the three things that I need to get from. In fact, I don't even need the V-in because it's only limited to this sheet. It doesn't go anywhere else in the circuit except over here. So I can ignore V-in as a hierarchical label. But the 5 volt and the ground needs to be connected to the external board. I'll choose hierarchical label, click here once, and call this 5 volts. It's an output because it's going from here as a power supply to the rest of the circuit. And click on OK. I'm going to use to rotate it. And I'm clicking it here once to place it like so. So that's my first hierarchical label. I'm going to create a second one here for ground. I click here once, label it as G and D. That's also an output. Rotate it, place it here. And now I can either just connect to the 5 volt and ground over here, or we can just add little stubs of wire over here like so, 1 and 2. And then use net name. Click here once, call this 5 volts, and the other one G and D. Place it here. We've still missed out on adding net labels to these wires. So let's quickly do that. I might as well just copy this 5 volt and place it here. Copy this ground and place it here. But the VN needs a fresh net label. So I'm going to click on this net label icon, click here once, and call it VN. Rotate it twice and keep it here. So that makes this pretty much complete. We have some action left to be done on the root sheet. So let's exit this sheet. And you can see this one is still blank and empty. There's really nothing over here. But those two hierarchical labels that we added, we need to bring it out over here. The way it works is you can right click over here, or there is a tool here that does the same thing for you. It says place hierarchical pin imported from the corresponding hierarchical label. So right click here. It says import sheet pins. Click on that once. You'll notice it's brought this 5 volt label for us over here. Click it once here so it gets placed. Right click once more. Click on import sheet pins. And you get the second one, which is ground. You place it over here. Repeating the process until you reach this point where it says no new hierarchical labels found. At this point, what's left is, let me click on the place wire icon, draw a short stub like so, draw a second stub like so, then go to place net label, click here once, click 5 volts, rotate it so it lines up like so, place it there. The other one, click once, type GND, enter, rotate twice, click and place. So that places the net labels on these corresponding hierarchical labels. That finishes the whole process of drawing a hierarchical sheet. And at this point, I think we have pretty much done the complete circuit. We can run the electrical rules check now to see if there are any errors that it detects and throws up. So click on this ladybird icon for performing the electrical rules check. That brings up your dialog. There are certain options, but the default ones, the ones that work the best. So let me go back to ERC and then click on run. There. And you'll notice it's thrown up 2 errors. Let's read for them. It says a pin is connected to another pin, but is not driven by any pin. It seems a bit odd, but what's happening is something that I can describe visually. Let's close this. If I click on this hyperlink, it will show up where the error is. Then let me close this. So here's the error, these 2 green arrows that you see. What it means is this one is a voltage regulator. And if you look at this symbol, let's open the symbol library, which is here. Let's look for the first icon. Let's use search for it. So 1117. And we had used the AP 1117. Click OK. So this is the symbol that we used. You'll notice that the 3 pins are power input for the VIN, power input for ground, and power output for VO, which is as they should be. Which means that VIN is expecting a power input coming from some source. There has to be a source that has a power output pin that is feeding this as a power input. But if we look at our battery symbol, for example, okay, this is the one we use. You'll notice that both the pins of the battery are passive, which means they are not really power output pins at all. And if we look at our connector, we had a pin socket. They are also passive pins. So what it effectively means is this one is an input, a power input pin, which is expecting to be supplied with juice from an external source. But everything that's connected to this pin, the capacitor, the battery, and this 2-pin header, don't have any power output pin on them. They are all passive pins. So it's not able to reconcile to that error. And the same thing with the ground pin as well. There are 2 ways of resolving this. One is to make the pins on this battery symbol as power outputs. But the other preferred way in Kicad is to add a flag here, which tells the circuit that this particular net is a powered net. And we do that using the power symbols library. So click on the place power port. We click here once. And what we're looking for is a flag. Type flag and you'll get this symbol called PWR flag. Select that, click on OK, and place it on this wire anywhere. Let's place it at this junction. And let's repeat that and place one more power flag on the ground. So we click here once. Recently used power flag. Okay. R twice to rotate it, place it here, and we have these 2 power flags. Now, what has happened is the power flag has a pin which is a power output, which means when you connect it here, this becomes a powered net, and the same thing with the V in net. And now if we run the ERC, you'll notice it finishes the check and the error list clears out. If you close this, you'll notice the green markers from here have disappeared. That's how the whole schematic capture process works. I have pretty much covered almost everything there is to it, except the custom library parts. Let's look at how that works. First of all, let's see what Kicad does by default. Here's our schematic, and if I open the folder where we have created this project, which is here, my desktop, there is also a library file, which is a cache that contains all of the symbols that you've used for these schematic. And that can be a useful thing to add to your project. So what we're going to do is, under Preferences, Manage Symbol Libraries, under Project Specific Libraries, I will click on the Add Existing Library to Table icon. And I can select this cache library and click on Open. So that makes it listed out over here under a project specific library, and click on OK. And that's one way of making sure that your project always opens up with using symbols from the cache library. So the best way is to actually grab all of these symbols and dump them in your own personal library. Let me see if I can quickly show you the easiest way to do this. We open the symbol editor, which is here. And first thing off, I create a new library, which I call tiny_blinky, and save it as a project library, not a global one. Click OK. Scroll down, you should see both of those libraries listed out here. So let's start by dumping all of these parts into a tiny blinky library. I can open up the symbol that I used was, also notice that multiple symbols have appeared for one part that we used. We used only the AP1117, but that's just an alias for a lot of other 3-pin regulators which have the same symbol. So all of them have ended up here. You don't have to copy and paste all of them. Let's just select this one, the 1117-5, and save it as this library. I'm copying it from the cache library to the main tiny blinky library and saving it. And it brings all of those aliases into my tiny blinky library. So that's the voltage regulator. Same thing with the AT-tiny. I can just select any one of them, but let's select the 8520. I'll click on it. File, save as, select tiny blinky, save, and then that brings all of the AT-tiny symbols into my tiny blinky library. Connector. Now, here's where things get a little bit odd. The cache library, when it saves a component or a symbol, adds the name of the library in front of the name of the symbol from that library. And that's sensible. But when we save it locally to our project library, we don't want to have the library name. We just want to name the symbol per se. So I'm going to edit this name by double clicking on it and deleting this connector, saying OK, then saying save it as tiny blinky, save, and that brings this connector over here from the cache library. And I can keep repeating that process. And then finally the push button switch. Select the switch, file, save as, push it to the new library and save it. Double click the name, edit the name to remove reference to the library. Click OK and save file. Let's revert the cache to where it was before changes, and then right click on this library to save it. And as a final step, we can now make sure that all of the paths within this schematic use a fresh library that we created, which is a project library, instead of the global library. There's a handy tool that lets you do that. You go to Tools and Edit Library Symbol References. What it allows you to do is take an existing component, which is a symbol from an existing library, and replace it with a symbol from a new library. So it's already filled out the current library column, and then the new library is the ones that I need to now add. I double click here. I open my library browser. Tiny Blinky, not the cache, and choose the 1x2 socket. Double click on that. So it's going to replace from the connector library and replace it with the same one from the Tiny Blinky library. And then we repeat this process for all of these parts one by one. It's going to be fairly quick. We can leave the power symbols as they are. So once I have made the table, I can click on Apply, click on OK, save. And if I look at any of these symbols, if I press E to edit, right click, properties, edit properties, you'll notice the library reference is now Tiny Blinky. So all of these symbols are now being picked up from my local library. This also allows us to actually modify our symbols. So let's look at that. For example, this one, switch, the library browser. So let's go to the creating, deleting, editing symbols, which opens up this. Let's scroll down to our library. And let's take the switch as an example. Double click on this. Say we want to change this symbol to something more fancy. I can delete these two lines. And on the left, I have a couple of drawing tools where I can place fresh pins, fresh text, or add polygons, circles, arcs. So let me choose the graphic rectangle and click once, drag up, and click another time. And I get this box here instead of a single line as earlier. And for the vertical line, I can just select that polygon icon, click here once, double click here to close it. Now, if you have bounded entities like a circle or a rectangle like this, you can double click on the edge to bring up a couple of properties. One is the line width. So we can change line width to mils to 10 or 20. In this case, we can leave it at 0, for example. And you can fill with a outline color, which is red in this case, or I can change it to a background color, which will make it a light shade of yellow. Let's make it a solid red background. I can even add an arrow over here by selecting the polygon tool, clicking here once, 1, 2, 3. That gives me a triangle. I can double click on the edge of the triangle and fill it with an outline color and get an arrow like so. Let's just save this. That's saved. Close it. You'll notice that the new symbol is reflected over here. So I'll leave it to you to try that out. If you have questions on that, you can always ask. So at this point, I think let's close down today's session. Thank you.